Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to my YouTube channel. My name is Sandy Ramadan. Today I'm gonna explain to you about my presentation, and the title is High Density Interconnect Microstrip Patch Antenna for 5G Base Station with Integrated Filtering Performance. Presented by me, Sandy Ramadan. So let's get to the matter. Oh, I almost forgot. If you ask me why I'm wearing a mask in this video, because it's part of campaign of healthy life during the COVID-19 pandemics. I still keep reminding everyone to wearing a mask, social distancing at least 2 meters, and still using a hand sanitizer. So I don't want to waste my time again. So let's get to the point. What is 5G? What is it? 5G or fifth generation is term used to refer the fifth generation as the next phase of the mobile telecommunication standard beyond the 4G standard, and the elementary radiator of the planar array for next generation millimeter wave or wave. 5G base station interconnected or HDI manufacturing for yielding a compact, densely interconnected and highly integrable stack structure. The layout of the single element is determined by directly optimizing key radiation feature of the whole planar arrangement according to the specific application-driven requirements. In addition, thanks to the exploitation of a spline shape modeling of the radiator, suitable performance in terms of impedance matching. Realized gain, half power bandwidth or HPBW, polarization purify, and inter-element isolation are achieved within the 28 GHz passband. Moreover, integrated out of the band filtering capabilities are obtained in a selected and wide non-contiguous stop bands without additional circuitry. Circuitry. Is there any problem or uh, limitation? Well, I'm gonna answering yes, because dealing with waves is one of the most critical and challenging tasks in releasing high performance of 5G base station. Is the design of innovative antennas able to simultaneously comply with several contrasting requirements on size, impedance matching, half power bandwidth, cross polarization, and isolation. Starting from this consideration, the design of a novel HDI manufactured wave planar array for 5G base station working in 28 GHz band is proposed here. Is exploited to simplify or efficiently describe in a wide set of possible geometric of the single radiator without recurring to a huge number of descriptors or degrees of freedom. Unlike conventional design methods, the synthesis of the single array element is carried out by directly optimizing with a customized particle swarm optimization algorithm. The radiation performance of the entire array layout to fill to fit all the user-defined requirements in terms of in-band behavior and the geometrical constraints, while exhibiting integrated filtering capabilities to yield the desired out-of-band rejection within wide and non-contiguous stop bands. That's the problem and the limitation. So let's get to next is analysis. Full wave, full wave validation in order to prove that the synthesis antenna properly radiates in the selected passband, while it enables suitable out-of-the-band filtering performance. Measure at the input port of the central embedded element matched to a reference input impedance of 50 when connecting all neckbirds to the match loads. Although the single element check in fundamental for the final design, the decisive analysis is on the radiation performance of the final planar uniformly spaced arrangement of the N25 of those elementary radiators. It turns out that the array behaves quite uniformly within the whole passband with reduced back radiation and a single main being properly directed towards broadside. Indeed, Gmax is always greater than the desired threshold. There is an increase of about 13.64 dB central frequency. Oh, I'm sorry. 13.64 dB with respect to Rayleigh's gain of the single element at the central frequency. Oh, sorry, my feet is hurt, so all right. So let's get back. There is an increase of about 13.64 dB with respect to the Rayleigh's gain of a single element at the central frequency, which is in a good agreement with the rule of thumb experimentally assessed in sine and increment within 12D and 15 dB is expected when displacing in array configuration between N16 and N32 elements. As expected, such gain values are obtained only in the antenna passband with a maximum value of Gmax. Otherwise, there is a fast drop of Gmax. Dealing with the bin resolution of the array, the project requirements are also satisfied since the HBW is always significantly below the desired threshold. HBW on both azimuthal and elevation cuts. Maximum maximum realized gain Gmax is 18. The result from the extensive analysis of about embedded elements and the full array have proved that the arising antenna is the rising antenna exhibit suitable in a band impedance matching. Signal rejection within wide non-continuous stop bands. Inter-elements isolation, HPBW, and polarization purify. So let's get to the next, and the last one is a conclusion. I think in this conclusion, in my opinion, a plan array for the future 5G wave or 28 GHz base station has been proposed. The antenna has been synthesized for HDI-based manufacturing technology with the objective of being compact or easy to integrate. The purpose of such a layer layout being the possibility to easily design buried routing and exploit high-density attributes, and having out of a band filtering capabilities without using dedicated circuitry. Yep, maybe that's all I can say. If there is any wrong ways, I'm sorry. Maybe that's from me, Sandy Ramadan. Yeah, good night everyone. Assalamualaikum warahmatullahi wabarakatuh. See you next time.